Welcome to a replay of one of our many excellent talks from Secure Southwest 15, and thanks again to our sponsors Securius, C3IA, CrowdStrike and the British Computer Society, and most importantly our prime sponsor the UK Government Department of Digital, Culture, Media and Sport.
So to the last presentation of the day, please welcome Achim from Exeter University, who's going to illustrate the link between digital security and privacy, a long day, privacy by design and the skills and needs thereof. Achim.
Yep, long day, and I also hope that except with that I don't know what is forward and backward. And now my slides are gone. No worries. Yep, okay, then let's start. Somewhat different and maybe controversial to a lot of the talks that we've seen today. I'm trying to not talk too much about my research, but more about the education aspect, because that's the kind of theme of the day. And when I ask my students what they actually want to become, then the first thing I hear is penetration tester. And we've seen that or heard that today already a lot, that's an important role in cybersecurity. A lot of trainings are being offered. It's one of the more technical roles. It's definitely widely sought after. We've heard that salaries are pretty good. And it's essentially required by companies of all sizes. Not that they necessarily employ them, but they might hire them as a service from a cybersecurity company offering pen testing services. We've also heard, and the last talk went a little bit into that direction, threat analyst, again, a very popular choice amongst our students, also widely sought after, maybe more required or employed by larger companies. I haven't seen threat analysts really utilized by SMEs. It's more kind of mid-sized and larger companies that use them. And of course, the big four consultancy companies employ a lot of them as well. And then what we've also heard, end user education, awareness trainings, all those kind of phishing or anti-phishing campaigns and things that we most likely all of us have received from our employers. Those kind of situations, you get the email, don't click on any links in your emails, and then 5 minutes later, you get an email from your IT department. Please click here to install that very important security patch. Not working too well. If I look at all those roles, and to be honest, a lot of what is being said today, there's one big problem. It's all firefighting. We are all looking how to fix security after we deployed our systems, our processes. We've just heard that the attack times, or the time between starting an attack and successfully rooting a device, went down over the last 2 years. What was it, from 9 hours to 1.5 hours? If we continue that craft doing bad data analysis, then essentially we wait another 1 year and it takes no time at all. That doesn't look very good. So we should think about what can we do instead doing that firefighting all the time. It still feels as we are designing systems and processes where security is an afterthought. And my examples are coming from software and hardware systems, because that's my background and my research interest, but consider them as an analogy for setting up your business, setting up your processes. If you start thinking, well, security, how to secure my processes, very late in designing a new business model, for example, then again, you're at the end that you need firefighters, and you need a lot of them. Of course, even if we build everything as secure as possible, we are still happy that we have firefighters, and we will need them, but hopefully much less often. If we look at the software security industry, there's one kind of keyword or catchphrase that they use called shift left. The idea of that catchphrase is you look at the traditional development process of a software system or IT systems, then again, we have all those kind of security assurance techniques penetration testing. On the very end of that process, and at least in the countries where we write from the left to the right, that means in our process graphics, those steps are on the right-hand side of the management slide. And then the security people came up, actually, we need to convince developers to do security tests, to learn about security vulnerabilities and do all that. Let's push that to the left side of the slide. That's essentially where that term originates from. I fear that in my previous life working in industry, I might be some of those guys that actually coined that term, and I'm responsible for its misuse. I'm feeling guilty. And it looks nice. Yeah, you ship stuff to the left. Essentially, after promoting that idea over the last 5 years, I guess, a lot of security people feel it more looks like this. And that's not because the software developers are not interested in security. It's just traditional security techniques that were designed for reacting for systems that are in operation or for doing an assessment as a final check before we deploy something are not the right tools and processes that work for software developers, for people that construct devices. Again, we also need to think about building something secure, or going back to the analogy of the firefighter, building a fireproof house is very challenging because you have to eradicate every possibility for an attacker to set a fire or to exploit a vulnerability, whereas the attacker only needs to find one weakness in the system. That's conceptually a little bit easier. So we need to change our approach in building systems. So can we learn something from other industries? If we look at traditional engineering, they start already at the design phase to think about safety margins. Traditionally, they are more focused on safety margins, but if you build a plane, if you build a vessel, if you build a house, you immediately think about, okay, I need the material in that thickness for regular use, and then you add some safety parameters to it. You increase, for example, the depth of a wall or so to increase its safety. Can we learn from that and integrate security by design? And the same is true for privacy critical applications. And yes, we can. And frighteningly enough, that idea is not a very recent one. It originates actually from a paper from 1985 by John Rushby, where he coined the term trusted computing base. And that is most likely one of the most misunderstood papers that we have in at least cybersecurity academia, or I would say in the development of highly security critical systems. Because people always understood that paper as, yep, you design your system, then you analyze the system to understand which is the core base of the system that you need to trust. The system that processes security critical data, privacy critical data, or stores those. And then you do a lot of magic, in that case, formal methods and formal verification. So mathematical complex processes and mathematical proofs to ensure that this part of the system is as secure as possible. Actually, that was not how this paper was intended. The intention of that paper was to motivate people to minimize that trusted computing base so that you can invest the required efforts to make it more secure. So the idea was start early. When you design your system, understand what are your security critical or privacy critical assets. Privacy-wise, data that you don't collect, you don't have privacy issues with. Security-wise, if a certain component doesn't process security critical data, then it's not a security critical component. And then focus the security critical parts to the small, trusted, minimized base and make that as secure as possible. Giving a very concrete example from many software shop systems, for example, don't spread the credit card data of your customers across all the different databases and systems components that you have. concentrate them in one aspect, in one part of your system, and make that secure. And that's most likely one of the reasons, besides the standards set up by the payment credit card industry, that most shops that we use in the internet use some third-party provider for the actual credit card payment, offloading all the security risks related in processing credit cards. And again, same is true for processes. There's currently, actually not currently, it started already 2013, I think, a big initiative by the British government called Digital Security by Design that follows that idea. It actually mainly focuses on developing an extension of ARM processors. In the meantime, there's also a variant for another processor architecture called RISC-V available that integrates right from the beginning into the processor design a lot of new security primitives that allows us to build more secure software systems. It was actually funded by the US DARPA organization together with the University of Cambridge. However, that worked out. And now, as I said, that program is something like 9 years ongoing. And finally, this year, for the first time, actually hardware boards will be available to work with on really redesigned systems. And that is something that we are doing in one research project that we are just starting together with a couple of companies and also the University of Coventry. That project is led by Beam Connectivity. That's a company focusing on autonomous cars and electric vehicles, so modern cars, as we all know. And they would like to understand in that project how they can utilize those new security features that digital security by design hardware provides to make car electronics more secure. So there are a lot of electronic control units in a modern car. Modern middle upper class car has something like 60 small PCs in there. They all run on software. They need to be updated. They send diagnostic data to the car manufacturer, maybe even your car insurance. There are models for that as well. That's privacy relevant information because you maybe don't want everybody to know where and when you're driving or where you're recharging your electric vehicle. They're safety critical in terms of they control your braking behavior, driving assistance systems and all those kind of things. And here on this project, we are really taking the opportunity to redesign new systems for existing use cases, trying to learn from the mistakes that have been done in the first iterations on traditional hardware and to explore how those new security features actually can help us to make those systems more secure so that we have a more safety critical and security critical electronics for cars. And that's something which really we should do much, much more often. Instead of doing iterative improvements, once in a while, taking a step back and really thinking right from the beginning, if I would do that from scratch, how could I minimize the components in technical systems or the process steps, if I'm more looking at an organization that need to handle security or privacy critical data. Essentially, we can also say that's an application of the need to know principle or a variation of it, which then really allows us to focus on the smaller parts and make them more secure with a proper investment. And that's really a call to action that I have to all of you, which I consider is something on the long term is very important to all of us, and maybe or hopefully will help us to bring that from 9 hours to 1 hour attack span time back again and reverse that trend so that it gets harder for attackers. So identify your critical components and then not leave it by identifying them. Think about if you can split them up. Is there functionality? Are there process steps in the critical path that actually doesn't need to have access to the security or privacy critical aspects of your system or your business processes? And can I refactor those so that those move into areas that are less security critical and don't make it harder to secure those parts that unavoidably have to work with the security and safety critical or privacy critical aspects of your business or system? So does this really solve the problem? In particular, what is the impact on that on the hiring problem? I claim, sadly, we make the hiring and education problem much more difficult. My experience is it is not too difficult to teach somebody at least the basics and the beginning of penetration testing to get somebody into that field. That works pretty well with a little bit of technical background, and I can build a curriculum to teach that. I can also teach people to design and build software systems. Combining both and really applying the knowledge of here are security critical components, how to refactor them, while it is a technical skill, it is a skill that requires a lot of experience in several areas. And that makes training people very, very challenging. And that's maybe also the reason why we had in earlier discussions that our professional skills, they are hard to teach because there's a lot related to experience. You have to make mistakes. You have to learn from them. You need to see and discuss how other people do things to actually improve. It's not something just read a book and do a couple of exercises and then it works. And that makes hiring much more difficult. Also in the modern world, we need to bring a lot of those activities that we have at the end of the security life cycle. We need to bring them on the left-hand side, or we at least need to build our systems that they work nicely. Part of a modern security privacy by design system that I would consider also important is designing those in such a way that they're easy to monitor. We've seen we need to have very quick response times. So the systems should be built with monitoring and threat analysis already in mind, which again means suddenly we need all that knowledge that threat analyst people have, that forensics people have in looking and analyzing actual incidents, to the people that design systems so that right from the beginning, they understand what information they should, for example, log to make the life for forensic analysis easier and provide all the evidences required. But I think it's a very rewarding work to do and a rewarding challenge to solve, because it also helps turning the security department, the security people, and that's the positive message, which I think fits nicely for the last talk, from a department of no to a department of enablement. We are more starting to think about how can we enable a certain business problem, how can we build a certain technical system while ensuring the privacy, while ensuring the security of data or the users which we are working with, instead of first letting people build something and then say, oh no, that's not a good idea. Don't do that. You're not allowed to ship that product, or that product is problematic in certain jurisdictions. I mean, a lot of us already might have experienced websites that since a couple of years don't serve customers from Europe anymore because they fear the impact of the GDPR. If they would have designed their systems right from the beginning with how can I do advertisement, for example, in a privacy-friendly way, they wouldn't have that problem. Yeah, and final slide. So again, we need to see security and privacy as an innovation power, not a roadblock. That's the really important message. And the one thing I would like you to remember from this talk, if you only remember one thing, it is something which we in Exeter in our security group are looking at from different perspectives for highly security critical systems. We are looking at new cryptographic applications. and systems that help us to achieve those goals. We are happy to help. And the final advertisement statement, matching nicely the education pieces. If you're interested in working in one of those areas, we currently have open PhD stipends. Thanks a lot.